is going to be very, very important to all of you, because this will tell you why data is important. This will also tell you the meaning of Six Sigma, right? If you pay proper attention, and this is going to go a long way. Even if you go to a program like MBB, this understanding can only help you, right? If some of you have already done a green belt or a black belt somewhere else, still this is going to be, an enriching session for you. And if you understand this, then you can understand, then you will find it easier to use any tools. This particular session, we are going to talk about the mean, standard deviation, specification limit, control limit, and then we will also understand what is sigma level, right? So little statistics is required to understand the meaning of Six Sigma, to understand how Six Sigma can help in any business. Most of the time, most of the people ask, sir, Six Sigma, is it applicable to my industry? I am into coding, I am into programming, I am developing software, I am into pharma industry, I am into healthcare industry, I am into education, be it, any domain. If there is a data, if you can see the problem through the data, then Six Sigma is applicable, right? Many a times people think that Six Sigma is applicable only in manufacturing industry. No, it is applicable in manufacturing as well as non-manufacturing industries. It is not only applicable in production department, also applicable in other departments. The other departments are assembly, your accounts, HR, your logistics, supply chain, marketing, sales, you name it. All departments can benefit out of Six Sigma initiative. What is required is there must be process inside your department. If you are running out of a process, if you really do not have any process, then you are too unsystematic, and you may find it difficult to embrace Six Sigma. But if there are process exist and you consistently follow the process, then Six Sigma is applicable. So all of you, do you understand? Who all can benefit from Six Sigma? And the answer is all of us can benefit. All industries can benefit by implementing Six Sigma, because ultimately Six Sigma is producing defect-free outputs, producing defect-free products, producing failure-free processes, right? That is the ultimate goal. So now see here, there are three scenarios I am showing you. First scenario, there is a parking area and a car. Similar setup for the second scenario and third scenario. Now tell me, which scenario is easy to handle and then, is creating a better environment? Is it the first one, second one, or third one?
Third one.
Third one. Because third one, you can park the car very easily. Am I right? And every time you park, your car can be safe. This ideology is nothing but Six Sigma. Every time you run a process, the output is defect-free. Am I right? 1,000 times you have to park a car. If you make your parking area in this manner, your parking area should be bigger than the car size. If the parking area is already constructed, then your car should be smaller in size. Am I right?
Yeah.
Similarly, in business also, if customer specifications are already decided, then control limits, you must see to that the control limits are coming inside the specification limit, because the parking area is already constructed. You can't go and change it, isn't it? Now your option is only to buy a car which is smaller in size. Similarly, if the customer specification limits are decided by the customer, now the only option is you can design a process ensuring that the extremities of the process, the extreme output of the process comes or appears inside the specification limit, so that every single time you run the process, the output is acceptable by the customer. All of you, do you understand my language? Yes? Yes or no?
Yes.
Yes.
Repeat, sir, please.
Yes, sir.
Okay. So only thing is here I used a term called control limit, right? Any process, see, any process will have some extreme cases. Am I right? If I
Yeah.
conduct the exam, somebody might score, 100 also. Extreme case. Somebody might score 0 also. Am I right?
Yeah.
Let us say the extreme cases in our current batch is 98 and 42. The 98 and 42 are the control limits. Clear?
Okay.
The 98 and 42 are the control limit, right? So if the complete data is available, you know the extreme cases. If complete data is not available, you can take a sample data and get an estimate of extreme cases. The estimate of extreme cases are nothing but control limits. All of you understand?
Yeah.
What do you think could be the extreme case in our training program if it comes to the exam mark? Can you tell me? What do you think you can achieve in the examination that we are going to conduct? Can somebody tell me?
60.
Come on, feel free to share. What do
Extreme
you think?
60%.
Yes. The
Extreme
possible extreme, not the theoretical extreme I'm asking. What is the possible extreme?
75.
How much?
75.
75. Very good. So 75 is upper limit. What do you think could be the lower limit?
60%. That is 40.
60%. So 60% is the okay, lower control limit. That means we are as a group, as a team, we are working on a process which can produce data within this 60 to 75. If you are going above 75, then you are special. Am I right?
Yeah.
You are a person, hardworking, self-driven. But if you are going below 60, then also you are special. You are not attentive. You are not listening. You are not following anything, right? So there is speciality you can observe if your data point goes beyond the extreme. Do you understand? Whether
Yes.
what's happening is special or not, which is helping us to understand the estimated extremes. Am I right? The estimated extremes from any process are called control limit. Here in the example in my slide, the parking area has got the walls on the right and left. Can you see that there is a wall on the right, there is a wall on the left?
Yes.
These
Yeah.
walls are pre-constructed. These are called specification limits. You can't change. Do you agree, all of you?
Yeah.
You can't go and say, no, say your customer to change the limits and all. It is for that requirement, he came to us. You
Yeah.
can't literally go and ask him to change. So these are called specification limits. You ended up purchasing this kind of car for some reason, right? And now your car size is found to be bigger than the parking area. If you don't understand this, still drive the car inside. What are you doing?
Damage.
You are causing damages. Similarly, after knowing the customer specification, you are designing a process. You design it wider. You design it wider. That process will definitely cause damages. All of you agree?
Yes.
So how do I know whether my process is wider or narrower? Wider is here, narrower is the last one. If the control limits, or if the distance between the control limits is smaller, process is narrower. Am I right?
Yeah.
When our Gautam was saying, he said 75 and 60. What is the gap? 15.
15.
15.
He knows there could be some form of inconsistency or poor control, so that people can score anywhere between 60 to 75. Isn't it? That's why, he said he gave a range. It is fundamentally the uncertainty that is widening your range. Am I right?
Yeah.
People may miss the classes. People may not go through the recordings, not go through the materials. Though you do everything, there is a chance, there is uncertainty involved. So how are you managing the uncertainty? If you manage well, the range will come down. Am I right?
Yeah.
Even if you do not attend the sessions, even if you do not read the material, still we can design a process more and more capable and still ensure each one of you qualify in the exam. Am I right? So how do you manage the uncertainty will decide your width of the process, right? The process can be wider, process can be narrower. A wider process for sure will create problem. A narrower process can ensure every time the output is acceptable. Understand all of you?
Yeah.
Yeah. And here the car is completely inside the parking area, so the process is considered capable. So the parking process is capable. Similarly, if the size of the process can be accommodated inside the specification limit, then the process can also be considered capable, right? And it is fundamentally the capability is measured based on the size of the process in relation to the size of the customer requirement, or you can call it as width of the customer specification. What is width of customer specification? Upper spec minus lower spec. Upper spec minus lower spec, right? So if the size of the process is smaller compared to the size of the requirement, process is capable. Process is capable. The car is completely inside. And now the second situation where the car is exactly similar to the parking area. Tell me, will you be able to park this car?
Yes, we can, but then there will be some minor defect, minor issues.
Certain situations, you may end up damaging your car, particularly, especially you are parking a car and you are getting a call from your girlfriend. You are trying to park this car and parallelly you are getting call from your girlfriend. Now what happens? You will miss the balance and your car is damaging, isn't it?
Yeah.
Possible. Sometimes you may get a call from your wife also. Then there will be a complete imbalance, right? And then there can be more damages. So if you want to tackle all scenarios, you should be cautious enough. You should be proactive. Better to have a small car. Similarly, better to have a smaller process. What is smaller process? The width of the process should be small. Width small means distance between upper limit and lower limit.
Lower limit.
Distance between maximum and minimum. What is difference between maximum and minimum?
Range.
What is difference between maximum and minimum? Range.
Range.
Range is the measure of variation in your data. If you can control the range, you can avoid many problems that can come. Am I right?
Yes.
And you can effectively manage your girlfriend, you can effectively manage your wife, and still you can park your car safely. Similarly, in business, there could be a lot of uncertainty, isn't it? The machines can undergo wear and tear. The settings can slightly change. An operator might suddenly take a leave. So all these uncertainty are part and parcel of any business. But in spite of all this uncertainty, your process will remain capable even in a long run. All of you do understand? This idea is Six Sigma. What is Six Sigma? Ensuring that the process spread is smaller compared to the width of the specification. All of you understand?
Yeah.
And now there is a runway, right? Aircraft runway, and you are going to be the pilot now. You can also see yourself sitting in the aircraft, which is Boeing or Airbus. And now there are 300 passengers sitting inside your aircraft. And now you have to land the aircraft from several miles above the ground. You are now flying. Now you have to land it. Now tell me, where will you try to land your aircraft? Will you try to land in the runway or outside the runway? Come on, please.
Exactly on the middle line.
Oh, I only asked a question, will you land in the runway or outside the runway? But Saurabh, has gone beyond. He's telling, sir, I will, land in the middle. Now I'm asking a question. Customer has given you a specification. Now you are producing a product, you are offering a service. Will you produce or offer the service inside the specification or outside the specification?
Inside.
Now, why are you not saying I will produce at the target? Here you said, I will land at the center. Because it is going to be a life threat, isn't it?
Yeah.
So you wanted to be more careful. So you wanted to stay at the center, the safest point. When customer is giving you a tolerance, I am asking you, why are you exploiting it? Why don't you say, I will produce at the target?
Right.
Customer wants, a 100 mm thickness plate. He gives a tolerance plus or minus 0.5. Instead of producing within the spec, can you produce around the target? What is target here?
100 mm.
100 mm. If you think to produce around the target, your thinking is Six Sigma. Now you are thinking in the Six Sigma language. All of you, do you understand?
Yeah.
Which means Saurabh is, cautiously, unconsciously is not only concerned about the variation, he is also concerned about the central tendency. How many of you can see that? In the previous slide, I only talked about the consequence of variation. If the range is more, failure can happen. But Saurabh is giving me another important information. Sir, even if the range is small, say for example, even if the car is small, still I can be drunken, I can go and hit the wall. Am I right, Saurabh?
Yes, possibility.
He don't want to, make such things happen. So he has not only purchased a small car, he also ensured that a proper driver drives the car. That means now he is concerned about central tendency. Central tendency means the center point of the car and center point of the parking area, he is trying to align. Am I correct?
Yes.
Same manner, the center point of your process and the customer target, can you align? If you align, your CP will be equal to CPK.
Yes.
Right? Your capability depends on two things. The central tendency, another thing is variation. What is our understanding now? Central tendency should be on the target. Variation should be small enough. Why do I say small enough? Because you should give room for natural variation. You should give some room for natural variation. You can't eliminate natural variation. You can't eliminate life from the earth, isn't it? So there should be life. So now I really appreciate Saurabh's thinking. He wanted to land at the center. That is, you could see the landing points of Saurabh, around the center. Can all of you understand why is he landing around the center? Because he wanted it. How many of you wanted to do this in your real business? If customer gives, sets a target, how many of you really strive to meet the target? How many of you are not willing to exploit the tolerance given by the customer? Always when freedom is given, people try to misuse. Am I correct?
Yes.
Similarly, when tolerance is given, we try to occupy it. Don't do it. Then your thinking is Six Sigma. All of you are with me so far?
Yeah.
Yes, sir.
So some of the landing points of Saurabh is here. All of them, I could see all of them are around the target. That means the intention is very good. He want to see to that all his 300 passengers are safe. He don't want to increase the risk of the passengers flying with him. So additional landing points. Now he is little bad now. Can you see that, all of you? Is landing, but it is possible because you cannot be perfect. More. If I collect enough data, I'll be able to realize certain things. Number one, deviation is happening. All of you agree?
Yes.
Deviation is happening because you cannot be perfect every time. And deviation can happen on the right side. Deviation can happen on the left side of the target also. All of you agree?
Yes.
And here is the maximum deviation observed. Here is the maximum deviation observed. Am I right? Am I right?
Yeah.
These are the control limits as far as this data is concerned. These are the extreme cases. But look at, tell me, is these extreme cases safe for your patients? Sorry, passengers?
Yeah.
No.
Extreme
No, they are not.
cases still safe for your passengers?
Yeah, to some
Yeah,
extent
yeah.
we can say yes.
Still you landed in the runway only.
Yes.
Yeah.
That means you are really a capable pilot. Your landing process is really capable. Even things go wrong, still you are able to land the aircraft in the runway. There is turbulence. There is some rain happening. That time, the deviation increases, but still the landing is safe for all the passengers. Similarly, if there are certain uncertainties happening in your business process, still your business process will produce acceptable products. All of you understand?
Yeah.
So if I visualize how my data is arranged, all of you, can you notice a bell curve getting formed automatically?
Yes.
This bell curve will form if you have enough data, if you collect enough data, right? So sufficient number of experiments you conduct, then definitely any data, any measurable data. What data? Measurable data. Measurable means it is a number. Measurable means there is a dimension attached. There is some unit available, centimeter, millimeter, microns, kilometer, calories, right? And Fahrenheit and kilonewtons. Some unit is available. Then all such data will follow normal distribution. If it is not following, you can, by modifying your data collection method, can make it follow the bell shape, so that you can draw meaningful conclusions. And now what is this one? This is the line where all the passengers inside expect you to land. Am I right?
Yeah.
Your process central tendency should align with it. Your process central tendency should align with it. What is central tendency? Average, mean, median, mode. These are the measures of central tendency. These are the statistical measures which will let you understand your process center. All of you, do you remember I told you in the previous slide, process center should align with the target. How can you see the center of the process? By calculating a statistics called average. If the process center aligns with the customer target, you are creating a healthy scenario for your business process. Am I correct?
Yeah.
So currently the scenario is healthy. And now what is this point? This point is the extreme landing.
Yeah.
Upper control limit. This point is the extreme landing on the other side. Lower control limit. Your runway ends here. That means upper specification. Customer don't want you to land beyond this line. Am I right?
Yeah.
In any case, you should be inside the runway only. Similarly, this is lower specification. So target, upper spec, lower spec, upper control limit, lower control limit. In any business, in any process, if the control limits stay inside specification limit, the process is capable. All of you understand?
Yeah.
If the control limits stay inside the specification limit, your process is capable. Control limit inside specification means almost everything inside specification. The uncertainty is less, right? So a process is considered capable if you can see the control limit inside the specification limit. If you can see the control limit well inside the specification limit, your process is now super capable. Am I right?
Yes.
If your control limit is seen exactly at the center, between the center line and upper spec, please listen to my statement. If the control limit is seen exactly at the center, between target and nearest to specification, I can say my process is doubly capable. Am I right?
Mm.
Or let me come to the statement little later. If I see my control limit on the specification limit, my process is just capable.
Yes.
Am I right?
Yes.
Sir.
If I see the control limit in the midway, I mean the midpoint between center and nearest to spec, my process is now doubly capable.
Mm.
A doubly
Correct.
capable process is called as Six Sigma process. All of you understand? A doubly capable process is called as a Six Sigma process. A process which is just capable is called as Three Sigma process.
Mhm.
All of you understand what is Three Sigma and what is Six Sigma?
No.
Let us say your monthly expense is 50,000 rupees.
Mm.
Monthly expense. Appropriate, right? 50,000 rupees per month. All your family expense. And your salary is also 50,000. Will you be happy now?
No.
No.
You just made it. 50,000 is the expense and 50,000 you are able to earn. But now what is the problem now? Why are you not happy?
Any
Because
moment
they're
it can
saving.
go beyond the line.
Yeah, December month there will be Christmas. January there will be New Year and Pongal. And October, November there will be Diwali. And that you will spend more than 50,000, isn't it?
Yeah.
So you want to be on the safer side. You will see to that. You will search for a better job. Am I right?
Yeah.
If your salary is 1 lakh, if the expense is only 50,000, you are now doubly capable.
Yes.
Even if the company pays the salary a little late, you will still run the show very beautifully. Am I right?
Yeah.
Yes, sir.
That's the advantage you get it. If you center your process properly and control the variation. If you control the variation, you are controlling control limit.
Right.
Right? All of you understand?
Yes, sir.
Yes.
So we learned certain things here. Customer target and process average should align. Am I right?
Yeah.
Drift is nothing but deviation. The deviation can be measured using a statistics called variation. One statistics which we already understood is range. You know range? Maximum minus minimum. The range can help us to understand the amount of variation. If the range is more, variation is more. Am I right?
Yeah.
There are other measures exist by which you can understand variation. One is standard deviation. One is standard deviation.
Standard deviation.
Another one is variance. Variance is nothing but square of standard deviation. Variance is nothing but square of standard deviation.
Square of
Whether you measure range, whether you measure standard deviation, or you measure variance, you are trying to understand variation. Please understand, all of you. Similarly, central tendency can be understood by calculating average, which is known as mean, which is also known as mean. You can understand central tendency using median also. You can understand central tendency using mode also. But for continuous measurable data, you can use mean. For countable data, you can use mode.
Mm.
For abnormal data, you can use median.
Mm.
All right. So ultimately, central tendency should be on the target.
Yeah.
Variation or deviation should be less.
Yes.
And now the customer limits are called specification limits. If you go beyond, it is a failure. That failure is an external failure. Because customer can now laugh at you. Am I right? But process will have a limit, natural limit. These are called natural limit. These are also called as control limit. if you see a point, if you see your product outside the control limit, something abnormal is happening, but this abnormality is not visible to the customer. Am I right?
Yeah.
But it should be visible to you. It should be visible to you. This is my definition of internal failure. A failure which is visible only to you, but not to your customer, can be considered as internal failure. Do you understand?
Yeah.
Now you are trying to be proactive. Do you understand? If you know what is internal failure, if you work on the internal failure, still you know it is work, still the product is working to the customer, but you don't want to supply that product. Customer says, no, I am ready to buy, but you are still denying the supply. You know why? If the customer buys such a product, very quickly it will fail. I mean, do you get my point?
Yeah.
Because you produced certain products around the control limit or around the specification limit. Where you should have produced? Around the customer target. Am I right?
Yeah.
All right. So let us not be very serious. And now I hope all of you have played this game, right? Shooting a balloon in the beach.
Yeah.
And now let us say the target balloon is the pink one in the center. Am I right? Or the red one.
Yeah.
And now you have to shoot. Now I am giving you a gun. And now tell me what is required so that you can hit this balloon correctly. Tell me what is required now.
The gun barrel should be straight enough so that the bullet reaches and its velocity should also.
Beautiful. The gun barrel should be straight enough. Is it straight enough?
Yes.
This is what we are checking here, whether the average is on the target or not. Do you understand the meaning, all of you? Whether the barrel is straight enough or not, whether the average is seen on the target or not, both have same meaning. All of you, can you realize that?
Yeah.
So your CP should be equal to CPK. That is why we want our CP to be equal to CPK. Otherwise, there is a problem in holding the gun. Your barrel is pointing the sky, but you are trying to hit the balloon. Do you think you will hit it?
No.
If the average is not on the target, you are not targeting properly. All of you, do you understand your mistake in the business? Now, another thing is, now I'm releasing the bullet, it is hitting. First time it is hitting. But I want to hit it repeatedly, the same balloon. That is the business, right?
Yeah.
So consistency is required. And if you look at my slide, consistently the bullets are hitting at the same point, absolutely zero deviation. Am I right?
Yeah.
Absolute zero deviation. Now, if you manage to collect some data of my shooting process, all your data will give a deviation of zero. Am I right? If you look at the data, the deviation will be zero because always the hitting point is same, no deviation.
Yeah.
But if I hit here and there, my variation will increase. How do I see? That is what I am looking at, the measures of variation. In order to understand whether I am consistently doing the right thing or not, I am looking at variation. It can be range, it can be standard deviation, it can be variance. If my range is high, what does it mean? I am shooting here and there, isn't it? All of you, do you understand?
Yeah.
If my range is more, I am hitting the other balloons also. But what is my job? Hitting the balloon at the center. Hope everybody is clear, right? What these statistics are telling us.
Yes.
Yes.
So now you need to hold the gun correctly and hit the target consistently. This is your job role. All of you understand your role and responsibility in the job?
Yeah.
If you are a process owner, if you are a manager, and if you are expected to take care of a KPI, make sure your data point, the average and the standard deviation are as per this requirement. And now there comes a new definition of quality. Can somebody read out the definition of quality?
Quality equal to f of x bar and sigma.
Quality is a function of x bar and sigma. Quality is a function of average and standard deviation. Can I say like that? If my average is on the target, if my sigma is very small, my quality will be best in class.
Mm.
A statistical definition of quality. Probably you may not read this in literatures. Clear?
Yeah.
And now if you want to play with the data, if you want to use data, right? You're concerned about business intelligence. You're concerned about data analytics. Then you must master this, concept called normal distribution. Because most of the time you will be able to see this graph only when you are playing with the data. I can collect all your, weight right now, and the weight will come out like this. There will be no average weight. There will be maximum weight. There will be minimum weight. Am I right? And most of you will have your body weight around the average only. Am I correct? Can you make a guess?
Correct.
There are 12 people here. What could be the average weight of the people attending the program? Come on, please.
70.
70. 70. If you are above 70, you are on the right side. If you are below 70, you are on the left side. Can you understand? Do you think there will be some people above 70 kg weight in this program?
Maybe.
Yes.
I am here. I am around this. I am about 72. Pradap, how much you are? You are also on the right side?
I am sir 65.
Okay, he comes on the left side. And Krishna, you are on the right side or left side?
Left side, around 65.
You are on the left side. And Gautam?
The left side, sir. 52.
Left side. Yadav?
On the right side, 92.
Saurav on the right side. And Yadav?
Same.
Right
Right.
side? Same means
Yeah.
which side?
Yeah. Right.
Right side. Can you see 50-50 chance?
Yes.
Approximately 50-50, right?
Yes.
That is an important property of normal distribution. The curve is symmetric at the center. Can you all see that?
Mm.
The curve is symmetric at the center. If you find out the average, approximately half of your data points will be above the average. Half of your data points will be below the average. Can you see that?
Yeah.
If you produce 100 mm thickness metal plate, half of your products will have dimensions slightly above 100. Half of your products will have dimensions slightly below 100. Am I correct?
Yes.
Exactly half of the value are to the left of the center and exactly half of the value are to the right of the center. If your data is sufficiently large, let us say there are 1,000 people attending the program. Very close to 50% will be above average. Very close to 50% will be below average. It can be 49.9 or 49.8 or something. Once you know the center line, the chance for a point to appear on the right side is 50%. The chance for a point to appear on the left side is 50%. Can all of you see that?
Yes.
Where is more chance for a point to appear? Where is the chance more for a point to appear? For example, what is the chance for somebody to have a weight above 100 kg? Anybody here above 100 kg?
No.
But somebody can come tomorrow, isn't it?
Yeah.
Somebody can come tomorrow with above 100 kg also, because where the selection criteria is not the weight. Anybody can join, isn't it?
Mm.
So the chance is very less. Can you see a lower probability here, this side?
Yeah.
Similarly, lower probability this side. Somebody with a weight less than 30 kg, 40 kg.
Yes.
Very, very lean person. So if you move away from the center, the chance for a point to appear is decreasing. Can you all understand?
Yeah.
So center line is understood, and I am drawing another line here. And in order to locate the line, I keep a distance equal to 1 sigma. What is 1 sigma? Sigma means standard deviation. I'll teach you how to calculate standard deviation. So 1 standard deviation, I have come to the right. Similarly, 1 standard deviation, I have come to the left. And now 68.27% of your data is expected to be inside these 2 lines. The average weight is 70 kg. Average weight is how much you said? 70 kg. If I collect all our data, 12 data, and calculate a standard deviation, let us say the standard deviation is 3 kg. What is the standard deviation? 3 kg. Now 70 plus or minus 3 kg. What are the limits? What are the limits?
67, 73.
This is 67, this is 73. Now, how many of us are having the body weight between 67 and 73? 68% approximately. Do you want to have a check? All of you can do it as an exercise, right? Today, all of you can have a separate meeting within yourself, note down all your weight and find out the average weight, find out the standard deviation and check what percentage of the people are within the limits called 1 sigma limits. All of you, can you understand the meaning of this?
Yes.
If the data is sufficient, you will see all these formulas working very effectively. That is the beauty of statistics. The beauty of statistics depends on amount of data and quality of data. All of you understand? One is amount of data, another one is quality of data. If you just take 3 data points and then check all these things, nothing will be satisfied. If you have 100 people and whatever I'm explaining now, you will be able to verify. Now I am moving one more distance by a distance equal to 1 more sigma. Now I am 2 sigma distance away from the center. Can you see this line?
Yes.
Similarly, this line. Now what percentage of the points are expected to lie inside 2 sigma limits? 2 sigma limits are called warning limits. 2 sigma limits are called warning limits. Already what percentage you covered up to 1 sigma? 68.
68 point.
Another 27% will now get added up. Now the percentage is 95%, which means 70 here, 70 minus 2 sigma, which is 64. 70 plus 6, which is 76. If I want to know how many of us are between the weight 64 kg and 76 kg, majority of us will fall in this category. Am I right? Anybody here above 95? Sorry, 76. Anybody here above 76?
Yes, me, sir.
Very good. You are above warning limit. Anybody here below 64? Nobody? Very good. That means 95% of your data, 95% of your data is expected inside warning limit. Am I correct with my statement?
Yes.
Yeah.
I want to go one more step. Now 3 more kg. 76 becomes 79. Saurabh, what is your weight?
Still, I'm not. Yeah, I'm 94.
Very good. So you should take some action. You reduce your weight. You are
Yeah.
not, your weight is not normal. You should come inside. All right. So here it is 3 sigma. The 3 sigma distance away from the center. Now the point is called control limit. This is going to be our borderline, our boundary line, the borderline between India and Pakistan. No, none of us should cross this. Right? And similarly, this side, lower control limit. And now almost everything is expected inside. Because the probability, the chance for a point to appear inside control limit is 99.73. Still, some mistakes can capitalize on the 0.27%. Can you realize? Right? The
Yeah.
mistakes, some uncertainty can capitalize. So the chance for a point to appear beyond the control limit is only 0.27. If this is happening, can you still consider that as normal? Do you understand?
No.
So now you must understand the necessity of coming inside the control limit. Am I right? This is what all of you should understand about the normal distribution curve. Everybody is clear with the concept?
Yeah.
If I add all the probability, the total probability will be 100%. Am I right?
Yes.
I will add even everything that can come beyond the 3 sigma. What is the probability to get a point beyond the control limit? 0.27. I am adding the 0.27 also. Now, what is the total probability?
100.
100%. The total area under the curve is 1. This is what we call it 100%. 1 means 100%, isn't it? 0.2 means 0.2 means 20%. 0.5 means 50%. All of it, you understand? I can consider 100 as 1. I can consider 100 as 1 million. I can consider this 100% as 1 million. So what is 1 million? 10 lakhs. Am I correct?
Yeah.
Now DPMO, defects per million opportunity. If I produce million products, now only 3 or 4 defects I can see. Right? So all these conclusions or estimations are done based on the knowledge of normal distribution only. If my language is million, then on the right side of the center line, how many products will I can see on the right side of the center line? 500,000. Am I right?
Yeah.
Similarly, 500,000 I can see on the left side. This is how you should use this knowledge in various scenario, various projects. All of you okay so far?
Yeah.
All of you, are you with me
Yeah,
so
yeah.
far? Are any
Yes.
questions to
Yeah,
me?
yeah.
Anybody would like to ask?
Yes.
Okay. And now imagine this is your village and these are the people living in that village. They have to, every day they have to cross the river. Every day they have to cross the river. And now if this is the scenario, in your life, you will try to understand a specific route which is safer for your people. Am I right?
Yeah.
So now the group leader here, he is trying to figure out which could be a better route for the people in that village. He finally, figured out 3 options: route A, route B, and route C. And now he himself risked his life. He walked through route A. He also walked through route B. He also walked through route C. And now when he was walking through route A, he captured certain information. How many data points? 1, 2, 3, 4, 5, 6. 6 points. What are these points? Which is important now? What is he measuring? Can somebody tell me?
Depth of that river.
This is CTQ now, critical to quality now. This is not critical to quality. This is critical to life.
Yes.
The depth of the river, right? So the metric, the number you look at should talk about the real problem. It should serve the real purpose. And now the depth is measured. What is the measuring unit?
Feet.
Feet. If you want to be, little more better, you can measure in terms of centimeter also. So predictions can be much better, right? So it depends. The physical unit you use, and the CTQ you use, very important. So now the depth is measured, here also measured, here also measured. The average depth of the river across the route A, route B, route C, all the 3 routes, the average is found to be 4 feet. Average is common. Does it mean all the 4 routes are safe to cross?
No.
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 Why are you
No.
saying no? Average is same.
But in C and B, the range starts from 7. The highest range is 7.
Range is very high in route C. Why are you seeing about range and all, Mr. Krishna?
Because for
If
a
the range
normal
is more,
person,
if the range is more, will it become a life threat for you?
yeah, because
Yes.
it probably average man can handle this, right?
See, if the range is more, then the conclusion you have drawn from the average can go wrong.
Yeah.
He thought that 4 feet we can cross the river. But when you actually cross, you may sink inside.
Yeah.
So always don't look at average separately, all of you. When you want to use the average, keep an eye on the
Right.
variation also. That is why God has given you two eyes. One eye will look at average, the other eye should look at
The variation.
variation. What you see through the first eye will be valid only if the variation is low. All of you understand?
Hmm.
So now let us use the other eye, which is our statistical eye. And now there is a data point. First root number A. How many data points you have? 6 data points. What is the average? 4 feet. All of you, do you know how to calculate average?
Yeah, sir.
Yes.
Now, deviation you have to calculate. What is deviation? Deviation from the average.
Yeah.
First data point is 4. What is the deviation for the first data point?
0.
No division. 0.
Your expectation and reality are same. Second data point, the depth is little far, little more. You expected 4 feet depth, but here it is 5 feet. How much is the uncertainty? Extra 1 feet, isn't it?
Yeah.
So plus means more depth, minus means less depth. The ups and downs in the root is visualized. The ups and downs is actually is the challenge. And if the challenge is more, it can become a life threat. So what is the total threat in this root A? Let me add up all the challenge. When I add up all the challenge, what is the total challenge?
0.
Does it mean there is no challenge in the root A?
No.
Challenge is there, but my
Yeah.
mathematics is wrong. So I go to statistics now. So square every number. Square every number. Now you can see number 6. Is this 6 talks about the challenge now?
Hmm.
This is called squared deviation. The squared deviation should be summed sigma x minus x bar whole square. That should be divided by the degree of freedom. Degree of freedom is n minus 1. N is number of data points. What is your n here? 6. 6 minus 1. And now this is called variance. All of you understand variance here? Variance of
Yeah.
1.2, is it acceptable or unacceptable? Are you able to take the decision looking at the variance?
Yeah.
Tell me, is this 1.2 acceptable or unacceptable?
Acceptable.
How do you say it
Acceptable.
is acceptable?
No.
Then is it
Okay.
unacceptable? Then also I will ask, how do you say it is unacceptable?
The thing is that there will be, we can expect a variation from 1.2 variation from the mean.
See, mean is expressed. What is the unit of the mean? Feet.
That feet.
Feet. But
Yeah.
it's 1.2. What is the unit of 1.2?
It's not
When I square the centimeter, it will become centimeter square.
centimeter square.
When I
Yeah.
square the feet, it will become square feet.
Yeah.
So difficult to work with the square. So take the square root.
Yeah.
Take the square root. Now 1.09. When you take square root of variance, it is now called standard deviation.
Yeah.
What will be the unit of standard deviation? Square root of square feet is feet.
Feet.
You are getting back a number with the same unit as that of average. Now you can judge whether this amount of deviation is livable or not. Am I right?
Yeah.
1 feet standard deviation, whether it is tolerable or not. All of you, do you understand why do we come to standard deviation instead of variance?
Yeah.
Now similar calculation for root B. I no need to explain, I believe. Similar calculation for root C. Now summary of all the calculation. And now tell me which root is safer now?
Root A.
Root A. Why?
Standard deviation is very less.
standard deviation is less compared to the other.
The
If the
other.
standard deviation is no, let us say it's only 0.2 across route A, then your walk through the route A will be, a walk in the park. Am I right? You will enjoy your walking through route A because it is perfectly flat. Can you see that?
Yeah.
Can all of you understand? Though there is a 4 feet of depth, people can enjoy walking through the river because it is 4 feet throughout. Your expectation can be a reality with a lower standard deviation. Expectation is average. Reality is derived from standard deviation. All of you, do you understand?
Yeah.
Expectation is understood from the average. Reality is understood from the variation. Here, expectation is okay, but reality is not okay. Can you see that? In comparison to this, am I right?
Yeah.
So with the help of average and standard deviation, you can predict better. You can predict better. Otherwise, the risk involved in your decision will be. So this is called concept of normal distribution. All of you, are you comfortable with the concept of normal distribution now? Okay, one of you, can you read out this statement?
Yeah. Standard deviation tells you how close or far the values of the data set are in relation to the mean.
All of you, do you understand what our Krishna is explaining? Yeah, all of you, please participate.
Yes, sir.
All of you are able to
Yes.
understand the meaning of standard deviation.
Yes.
Yes,
sir.
yes.
All right, this is what all of you have studied in 7th standard while doing the schooling. Sigma equal to square root of summation of x minus x bar the whole square divided by n minus 1. Some teacher could have taught you. But now is
Yes,
the time.
yes.
Now is the time. You should use this in your business. Right? You should use this for decision making. And now, can somebody read out this statement?
99.73% of the area by points under the curve will lie inside 3 sigma limits.
Very good. Thank you.
Limits, control
Extreme
limits.
control limit. The 3 sigma limits are known as the extreme output or the control limits. You can expect 99.73% of the area or 99.73% of the points to lie inside the control limit. The points are nothing but your products. Am I right?
Yes.
The points are nothing but your products. Points are nothing but the characteristics in your product. Points are nothing but the characteristics in your service. You can expect 99.73% of your product characteristics to lie inside control limit. So take care of the control limit. Now you are taking care of everything. Do you understand? All of you, do you understand?
Yeah.
Yes, sir.
Yes, yes.
If I take the class in a way that even a worst student can learn, that means the entire class is learning from me. Am I right?
Yes.
Similarly, if you make the extreme outputs that are coming out of your process acceptable by the customer, it simply means everything is now acceptable. Am I right? And see here, if the control limit overlap with the specification limit, if the control limit overlap with the specification limit, the inference you can draw or the conclusion you can make is 99.73% of the products will be accepted by the customer. Why am I talking like this? My control limit is seen on the specification limit. Because it is beyond the specification, customer will reject my product. So if my control limit is overlapping with the specification limit, what percentage of the products are expected to be accepted?
99.73.
Very good. Now see, with the help of two numbers, average and standard deviation, you are now able to you are now able to understand the routes across the river, isn't it? The route A is the best for your people. Now somebody tell me, how many points are there along route A? How many points are there?
6 was in the route.
See, 6 is the point, 6 is the number of points we measured. That is our sample. I am
Okay.
asking about total number of points that are there along route A. How many points are there?
Didn't get that.
So there were 6 points.
So 6 is the number of points we actually collected.
There are n number of
Total,
points.
what will be the total number of points along route A?
9.
9 points, only 9 points.
N number of points, right? Oh,
N
N
number of points. I appreciate the statement. N can be infinity.
Yeah.
N can be infinity. You are producing N number of parts. You are serving to N number of customers. N can be infinity. Am I right?
Yeah.
But what what will be the quality of all these N unit? I can judge with the help of 6 points or 7 points, 3 points. It depends. This is called sample. The 6 point is the sample.
Hmm.
The infinite number of point is the population. With the help of the sample, I have estimated the quality of the population. All of you, do you understand? Sample is
Yeah.
helping us to understand the population. If 6 points are like this, then all n number of points will be like this only. Am I right?
Yeah.
Now you are walking along the river. Tell me, how will you choose the 6 point? All the 6 points will you choose in the river bed? Or
No.
will you choose some point in the center?
No.
Tell me, how
From
will you
the
choose 6
beginning-
points? You have to select only 6 points across the river. Now, let us go to the river. Tell me, across route A, will you take all 6 points from the river bed only?
No.
You will
No,
go
sir.
wrong.
So I'll the entire distance around we classify into
You
that
will select
strata.
points covering the entire distance. Am I right?
Yeah.
You will hold a stick and measure throughout the route. Preferably, you will take more measurements in the center of the river. Am I right?
Correct.
Yes.
Because what is your understanding? In the center, 68% of the risk will be there in the center only. Am I right? You take 68% of your data around the center. All of you understand? Take remaining 32 outside. 16 this side, 16 that side. Now it is important that you measure, in the riverbed also, nothing wrong, because here the depth is low. You measure, take some points, few points on the riverbed this side, few points on the riverbed that side, but more points in the center. Can you be more realistic now?
Yeah.
This is called sampling technique.
Okay.
This is called sampling technique. If you use a wrong technique, you will go wrong. You will become mad with your data. Am I right? All the 6 points, if I take here, all my predictions will be wrong. Am I correct or not?
Yes.
Yeah.
Use the appropriate sampling technique. That is the reason why we are teaching all these tools. But you should know how to use them, all the tools. How do you use the tool is called the technique. The right tool used in a wrong way, wrong technique, cannot give result. Am I right?
Yes.
All these things we learned. And now, you are now able to explain, you are now able to talk about the, route along, route A in the river. You are able to talk about route B. You are able to talk about route C. Same manner, you can find answer for many, many challenging questions. How many dolphins are there? Will you be able to count every dolphin in the sea?
No.
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 But you need an answer. Now statistics is the way. You can only get an estimate of the dolphin population. Am I right?
Yeah.
That estimate is generally a range. The estimate will be generally a range. When I ask you how much mark will you score, you said 60 to 75. Can you see a range here?
Yeah.
The endpoints are called your confidence limits. The endpoints are called your confidence limits. And now, what proportion of the products will get accepted? You have done a trial run. You have done a trial run. And now, will you be able to judge on, what percentage of the products will be accepted by the customer? Possible. Possible or not? Possible. Isn't it?
Yes.
You have to do the trial run, exactly simulating the real conditions. Then your judgment, your estimation can be realistic. I want to launch a product. I want to know what proportion of the customers in a particular locality will buy my product. I am an ice cream manufacturer. I have come out with a new flavor. There are 10,000 people in that locality. What percentage of the people will like my ice cream now? Do you get my point? Because I don't want to end up, launching a wrong product in the market. So I do a small, pilot study. Probably, one day I'll give free ice cream to 100 people, 1,000 people, and ask their feedback. Will it give me a meaningful result?
No.
Yes or no?
To my knowledge, no. Probably no. Yeah. About the quality of the product, yeah, maybe yes. But whether it will lead to the business, probably no, because we are giving it.
When you are walking through the river, I told you to measure the depth of the river, not the taste of the river. When you are doing a survey, you conduct a survey in a way that you understand whether the customer can buy the product if it is launched in their area. So you design your questionnaire in a way that you capture the right information.
Yeah.
But still, there will be some amount of uncertainty. Always, that uncertainty will increase your confidence interval. The interval, if it is increasing too high, your study will lose its meaning. For example, all of you are expected to score between 0 to 100 in the exam. Now, my statement, lose its, what do you call, respect. Because anyway, everybody is going to score between 0 and 100 only, isn't it?
Yeah.
So if the confidence interval is too wider, then the study will lose its value. A study is considered valuable only if the interval is
Low. Yeah.
smaller. How can you make the interval smaller? By increasing your quality of sampling. By increasing your quantum of sampling. There are 10,000 people. If required, I will do a survey with 5,000 people. Am I right?
Yeah.
Now tell me, average is a measure of central tendency or variation.
Central tendency.
Central tendency.
Standard deviation is a measure of consistency, inconsistency. I want to add one more option, both.
Variation.
Central.
It can be both.
Standard deviation.
Right?
It can be both. Yes.
If standard deviation is low,
That means that means
Consistency is less.
standard deviation
inconsistent.
is high, inconsistency. You can use it to measure anything. What proportion of the points will lie inside control limit? I'm not getting, quick answers. I do not know whether all of you are
99.7.
listening to me carefully. 99.7. Standard deviation is always quantified as a positive value. Is this statement true or false?
True.
It's true.
See, all of you can answer, right? And I'm creating opportunity for all of you. So all of you can unmute and
True.
answer. Yeah.
That's true.
Normal distribution is symmetrical about center. Is this true or false?
True, sir.
True.
Very good. Total area under the normal distribution curve is 100%.
Yes, sir.
Yes.
True.
True.
If control limits stay inside specification limit, the process is considered capable or not capable.
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 Specification limits are provided by
Customer.
Customer.
customer. Control limits are calculated using
Process data.
Process data. Control.
Both data.
very good. Now
Process
you are ready to use statistics in your business. You are ready to see the transformation. So what is Six Sigma? Six Sigma is a methodology by which we can reduce defects by controlling the variation and controlling the central tendency. Do you understand? I'm not reading out what is written on the slide. Right? Slide is giving you a lighter information. I can reduce the defects because defects is a function of two characteristics. The average, another one is standard deviation. So reduce the variation, also control the central tendency. How will you control the central tendency? You must see the central tendency on the target. Am I right? Yes or no?
Yes, sir.
You are sending your children to school. You must see your children only inside the school, isn't it? Not in the cinema theaters.
Yes.
If they are in the cinema theaters, they are not learning. If your average is not on the target, it is away from the target, you can understand your kids are now enjoying a movie, not learning. All right. So two things you need to check. And there are two methodology to handle different scenario. DMAT, it is for correcting the existing failures. DMAT B, it is for preventing the future failures, which is, like new product development or building a new process or developing a new design, developing a new layout. And now let us understand Six Sigma in a context. And I have slides ready with, for the case of a call taxi service. I hope all of you know call taxi service, right? It's a service industry. Can somebody tell me one important CTQ in a call taxi service? One important CTQ, critical to quality.
Arriving time, sir.
Arriving
time.
time. Suppose if it is a company like Swiggy or Zomato, what is the CTQ?
Delivery time.
Delivery time. Do you know an important CTQ in your business? All of you?
Yes.
I want all of you to share one important CTQ which you are responsible for in your business.
Timeline.
In our WhatsApp group. Will you do it?
Yeah.
If required, you can add a definition also. Isn't it? Delivery time, everybody knows what is delivery time. Isn't it? Food delivery time. When I order the food, right? It is not the delivery time for baby, which is 10 months. But the food delivery time is the time between the order is placed and the order is arrived. This is definition called operational definition. All of you, can you promise me to share one CTQ in the group so that we all can learn from it along with the definition? Yes, please, right? And now let us work with, the call taxi service, car arrival time. Can somebody define what is car arrival time?
The time taken to reach the time taken to the time difference between the booking time and the car entry time.
Very
That
good.
car
The
arrival.
time difference, the time between the booking and the car arrival. That is why now these companies are collecting OTP only to capture the CTQ. Isn't it? Once they arrive, they will ask you to give the OTP so that they understand, okay, whether the car has arrived within the committed time or not. Once you book, automatically the time will be captured. Am I right?
Yeah.
Yes.
They are collecting data. They're collecting data, and that's the reason why their business has grown like anything. Isn't it?
Yes.
Millions of cars are running for Ola and Uber. They are not owning any of the cars because they are working with the correct CTQ. Wrong CTQs will, will lead your business in a wrong direction. You might be spending your resources in the wrong place. But right CTQs can lead your business in the correct direction, and then your business can grow. So here the CTQ is car arrival time, right? And let us consider a case where the cars are expected to arrive within 30 minutes. We are now trying to solve a problem for Ola or Uber, where whenever a booking is done, whenever a car is expected to arrive within 30 minutes, that's where Ola is struggling. All of you, do you understand? If the time to get a car, if it is 90 minutes or 100 minutes, then there is no problem. Drivers are able to reach. But if it is less than 30 minutes, if the app says less than 30 minutes, then there is a lot of challenge. Most of the time, the cars are arriving beyond the expected time. As a result, there is a penalty. All of you, do you understand the situation?
Yes.
Yeah.
Now, what is the upper specification limit?
30 minutes.
30 minutes. What is the lower specification limit?
15.
0.
It can be 0. Theoretically, it can be 0. Theoretically, it can be 0. But if you want to keep 0, then you must have so many cars. A car in front of every house. That's not possible, right? So there will be some time required so that the car can move and then come to your place. So I'm going to assume 10 minutes as the lower spec. Is that okay to all of you?
Yeah.
10 minutes is the lower
Yes.
spec. 30 minutes is the upper spec. The center point between the lower spec and upper spec is always the target.
Yeah.
So what is your targeted arrival time for that locality?
50.
Center point between 10 and 30.
20.
Center point between 10 and 30.
20.
20. So 20 is the target, plus or minus 10. Plus or minus 10 is the tolerance, right? Plus 10 will give you upper spec, minus 10 will give you lower spec. The process is now two-tailed process. But actually it is one-tailed only. The failure is sensitive only on the right side. Am I right?
Yes.
If the car arrives before 10 minutes, it's not a failure. Am I right? But if the car arrives too early, then it is not good for the business. Am I right?
Yeah.
So 10 and 30, I'm explaining it as a two-tailed process, but in reality, it is one-tailed only. We'll adjust it towards the end of the discussion. Every time, if a car is arriving within this limit, your call taxi process is capable. And now I visualized the requirement. Can you all see upper spec, lower spec, and the targeted value?
Yeah.
What is the specification width you are seeing here? What is the specification width?
20.
20.
What is the unit? What is the unit of 20? Minutes. 20 minutes. And specification width, what is the formula? USL minus AS.
Yeah.
This specification width is nothing but the numerator in your CP. If some of you have used to see CP in your business, the numerator is specification width. And now, how is my process? How is my process with respect to the customer requirement? Now, I picked up all the bookings that happened in the last 1 month. All the 30-minute bookings in the last 1 month, data is captured. You may have thousands of bookings, am I right?
Yes.
And now 1,000 data points are available. Can you calculate the average using the 1,000 data point? That is this line. Can you all see the green color line?
Yes.
What is this green color line? Process
Average.
average.
It's
Process average is found to be 20 minutes. What is that? What is that? The customer target here, or what is the design target here? 20 minutes. See here, design target 20.
yeah.
And design and the real process are matching. Can you see that?
Yes.
That means
sir.
your process is under full control And whatever the design of the way the process is expected to function, it is functioning in the same manner. I could see that by seeing my average on the target. The average is X bar, target is mu. Now your kid is inside the classroom, listening to the teacher. That is understood. Now for the same data, I am calculating sigma. What is sigma? Standard deviation. Average has told me that my kid is inside the classroom. Sigma is telling me that whether my kid is attentive, really listening. All of you understand?
Yeah.
Sometimes kids may be inside the classroom, but still not learning, doing something else. Same manner, my process is on the target, but still, is it producing fruitful result? I am checking sigma. Let us assume a sigma value here, 3.33. Because we require data to calculate. I have taught you how to calculate data, but sigma is 3.33. Once sigma is available, average is available, will you be able to calculate control limit? What is our understanding about the control limit? 3 sigma distance away from the center. Am I right?
Yeah.
Sigma is 3.33. What will be 3 sigma then?
1.
3.33 into 3 is
9.99.
9.99.
0.99. Approximately, yeah, round it to 10. 20 here, 20 plus 10, 30. All of you understand your
Yes.
control limit now, upper control limit. Now lower control limit is 10.
Understand.
Now you can understand your process width. What is your upper control limit minus lower control limit? That is how much?
20.
20 minutes. So specification width also 20 minutes, process width also 20 minutes. Your process is just capable. Am I right?
Yes.
Because when I overlap the specification limits and the control limit, I can see them exactly overlapping.
Yeah.
My process is just capable. This is called 3 sigma process. This is the time your CP will be equal to 1. All of you understand what is CP now?
Yeah.
CP is the ratio between specification width and process width. Process width is always 3 sigma on the right side, 3 sigma on the left side, so 6 sigma. You can replace the formula UCL minus LCL by the term 6 sigma. Am I right?
Yes.
So specification width divided by process width, you will get 1. CP equal to 1 means your process is just capable. But just capable process is like, parking your car in a parking area, exactly, similar in size.
Right.
And now girlfriend is calling. You will lose the balance or you will still maintain the balance.
Lose the balance.
So that uncertainty is involved, right? So that uncertainty, how do you see in business? That uncertainty will reflect in the green color line. Am I right?
Mm.
That uncertainty will reflect in the width of the process. The imbalance will increase the process width. If the process width increases, control limit can stretch outside. Control limit can stretch outside, both on the right side as well as on the left side, if you allow the process width to increase. How do I know whether process width is increasing or not? I look at sigma. Am I right? If sigma is increasing, what will happen? Control limit can go beyond specification limit.
Mm.
One more way problem can happen. The center line can shift to the right or left. Your child is now trying to escape from the classroom. He is going to the playground. Do you understand?
Yeah.
The child is now not in the classroom. Class is going on, but your child is in the playground. When the child is in the playground, do you think the learning will happen now?
No.
Class is happening in the classroom. And now what will happen is control limit then also will go beyond specification limit. Am I right?
Yeah.
Yeah.
When the situation is like this, your process, is just capable. You just made it. Now I want to give this process a nickname.
Yeah.
Elephant process. What is this called? Elephant process. Why do I use the word elephant here? Because you just have to understand that you have logged a big animal, elephant, in a room which is exactly equal to the size of the elephant. Can you do like that? Are you giving justice? If I give you 6 feet
No,
by
no.
2 feet, I give you 6 feet by 2 feet room. Will you like it?
No, sir.
They'll give it in the end, isn't it? But now we all deserve a bigger room. Similarly, your process deserve a bigger room. So right now, this process, though it looks capable, it is not good considering the future, right? This animal can no more stay in that room. It will try to stretch out. If the animal try to stretch out, what will happen to the walls? Walls will get broken, isn't it? Let me show you how, right now under this situation, look at the failure. The failure is here. How much is this failure? What is our statistical estimation?
0.27.
0.27.
0.27, yeah.
Is your business going good? Looks going good. Am I right? Your
Yeah.
business looks going good. Because your yield is now 99.73. Your yield is how much now? 99.73. Your rejection is only 0.27. Are you happy now? You should be happy. Right? But what happens is, this elephant cannot stand in that room for a longer period. Am I correct with my statement?
Yeah.
So the elephant is moving out. Now the walls are broken. Now you are sleeping on the next room. Now the elephant is, next to your bed. Do you understand? So how do you know? And you can, since the entire process has moved, you can see the control limit also moving out. Am I right?
Yeah.
Similarly, in your business also, process can shift. Possible or not? You designed it here, but after 2 months, after 3 months, you are seeing your elephant here. How do I know? My control limit is now moved out. And now what is the damage this is causing? Now the damage, do you think the damage is still 0.27?
No.
It is now more than 10%. A process which was designed with a CP value of 1 looks to be promising at the time of design. But after 3 months, after 6 months, the failure rate is 10%. All of you, do you understand why there is 10% rejection in your process? You have designed it correctly, but not considering the future challenges. All of you understand? So now, in order to take care of the future requirement, in order to take care of the future challenges, future uncertainties, you must consider, improving your process further. Improving the process further means you should correct the process center, you should correct the process variation. Center is already perfect. Am I right?
Yeah.
Center is already perfect. All that I can do is I can work on the standard deviation. Look at my standard deviation. Standard deviation is reduced from 3.33 to 1.66. Can somebody tell me how can I reduce standard deviation in the call taxi service? I want my process to be, much more consistent. How can I make it happen? Give me some ideas, brainstorming. Can I increase the number of cars?
Yes, we have to increase the car.
Idea, good idea. What else can be done? Can I train my drivers?
Yes, sir.
I'll train them on the process, whole process. I will explain them what are they supposed to do when a booking is received. Don't delay further, isn't it? Immediately move the vehicle towards the customer. Am I
And
right?
yes, sir. Sir, and one idea is
Yes,
if
sir.
within the time our car is not available, then frankly train our employee. Frankly tell that this time you will not get our car.
Okay, but that's that is not serving our business.
Yeah,
We must grab all the opportunities, right? So,
Yes, sir.
but you are understanding your customers' situation. You are giving that answer. But then, from the business perspective, you should be able to process every single order that is coming.
Or sir, we tie up with another company.
Yes, yes, that's what you are increasing the cars. You do it in,
Yeah.
you can have any strategy. And can I consider, proper maintenance of the vehicle now,
Yes, sir.
right?
Improving mileage, sir. Car
I
mileage.
can also consider improving the GPS system. The customer care service can be little more better. If I do all these things, do you think that will reflect in my standard deviation? Yes or no?
No,
Yes.
If it is no, tell me why no. We are
Sir.
giving you better teaching. We are conducting extra classes. Do you think all of you will start passing in the exam?
sir, my understanding is we are solving the problem of the timing which is required
Yes,
from the point it is booked till the point it reaches your residence or the point where you have.
yes, yes.
So all the answers which are given, I mean, yeah, they can be relatable, but will not solve the exact problem.
See, earlier in the previous scenario, in that particular locality, I had 200 cars. But understanding the problem, I increased it to 500.
Mm.
Now extra cars are attached. Now every 1 kilometer there is a car available.
Yeah.
And now do you think I'll be able to impact the car arrival time now?
Yes.
Yes, it is possible. It is possible. That's you, but I really appreciate your thinking because we need to work on the correct CTQs.
Yeah.
Correct CTQs and correct critical factors. The number of cars is a critical factor. Ensuring availability of a car every single kilometer is the X factor, not the maintenance of the car, isn't it? That's what you mean to say, isn't it?
Yes. Yes.
Whether the car, but that will also have some impact, maybe a lesser impact. Car can break down on the way, and that can be a reason.
Of course.
But the major reason is insufficiency of the cars. So the factor which has a major impact is nothing but the critical factor. Critical factor can be one, critical factor can be many also.
Yeah.
Right? All the critical factors are called root causes.
Yes.
All the critical factors are called root causes. Now, sigma, I could see that I have attacked the correct X factor, and that is now reflecting in my sigma. Sigma is reduced to off. Since sigma is reduced to off, can you see your process width reducing to off?
Yeah.
Now you are not exploiting the tolerance that has been given. Though the tolerance is given, you are only using half of it. Now you are respecting Takuchi's philosophy of quality that was taught on day one. Am I right?
Mm.
Variation, you are ensuring that variation is less. Now your process is doubly capable. You have brought the center line to the center, midway between process center and the specification. Now your process is doubly capable. If you calculate CP now, specification width by process width, 20 by 10, your CP is double now. Am I right?
Yeah.
In terms of sigma level, it is called 6 sigma process. Why do I call it 6 sigma? Count the distance between process center and nearest spec. How much is this distance, center to specification? How much is this distance? 20?
20. No, not 20.
10.
10.
10. Okay, 10. That 10 in terms of number of sigmas. How do I get 10 in terms of number of sigmas? That 10 must be divided by standard deviation. That 10 must be divided by standard deviation. How much is standard deviation?
1.66.
So 10 divided by 1.66. Tell me.
And
Little max is required.
6.02.
6.02. So that is why you are seeing 6 sigmas. Can you see here? All of you, can you see 6 sigmas here? It is simply because the mathematics behind is the distance 10 is expressed in terms of number of sigmas. So the process is called a 6 sigma process. In the previous case, you can call this process as 3 sigma process. You know why? Here also the distance is 10. But how much is your sigma here? 3.3.
3.33.
10 by 3.33 is 3 sigmas. Can you see 3 sigmas here?
Yes.
Same manner, here you can see 6 sigmas. So the process is 6 sigma. Your process is doubly capable. If you
Yeah.
make your process doubly capable, it will look narrower. It will look taller in the center. That means you converted the elephant into giraffe now. Doubly capable, right? And now, if something goes wrong, the process can shift. Statistically, it is estimated that a process can shift only by a distance of 1.5 sigma, not more than that. The process can shift only by 1.5 sigma. See here, after 1.5 sigma shift, where is your new control limit? Since the process is shifted by 1.5 sigma, control limit will also shift by 1.5 sigma. Even after shifting, can you see the control limit still inside the specification limit?
Yeah.
Even if there is some future challenge is considered, then also your process remains capable. You are missing 1 or 2 classes. Still you are passing the exam. How? Tell me. Some of you have not attended yesterday, but still you are going to come out successfully. How?
Because yesterday's lessons are again, revisited by giving examples.
Very good. So your process is designed to take care of these kind of uncertainties. That's how you are preventing a failure. Now you are proactive in your process. Can you understand? And now, this is the region or this is the output beyond my control limit. Out of this, red color output, only a small portion is going beyond specification limit. Can you see that?
Yeah.
This is what we call it 3.4 dPMO. What is dPMO here? Defects per million opportunities. Only 3 or 4 defects out of 1 million opportunities. 1 million booking happens. Only 3 or 4 bookings. Car is arriving late. All of you, can you understand?
Yeah.
Now the success rate, failure rate is very low. Success rate now is 99.999%. How much? 99.999%. And now look at my slide and tell me, what is this process? Is it an elephant or a giraffe?
Elephant.
Statistically, what is the sigma level?
3 sigma level.
3 sigma.
This is my level.
That is what we call it, G score. 3 sigma. That is what we call it, G score. This we will be teaching you again at a later stage. But the meaning is here. G score is the difference between process center and nearest to spec divided by standard deviation. That will give you G score. So G score is 3 because there are 3 sigmas here.
Yeah.
And now success rate is 99.73. But this success rate is only short-term success. In long term, damage can be much more. Am I right or not?
Yes.
We have seen 10% rejection. And now I'm showing you another process. And now tell me, what is this process? Is it still an elephant or a giraffe?
Giraffe.
Giraffe now.
6 sigma.
Yeah, in terms of statistics, it is 6 sigma process. You can see the control limit well inside the spec. Now, what could be the success rate you can expect now?
99.9.
99.999. If at all there are failures, the failure will definitely be less than 3.4 dPm. Provided the failure is considered only on one side. Now, this formula, how do I get all these number? I get all these number from the G score. There is a distribution table called a normal distribution table. In that table, these kind of solutions are ready-made available. When G score is 4.5, this will be your success rate. What level of success you want to achieve in your business, the table is already created. If you want 100, if you want 90% success, you can pick up, you can understand the G score. And G score is a function of your X bar and standard deviation. Hope everybody understand, right? So
Right.
ready-made solution is available, and that's how statistician, as a Six Sigma expert, you can help any business. And now, if the process is one-tailed means only one side failure is sensitive. Am I right?
Mhm.
So your success rate can be little more better than 99.999. Can you see the success rate now? 99.999, 666%. That is how 3.4 is derived. As a secret number, a benchmark number set by Bill Smith and Michael Harry. This is how it is derived. And if the process is two-tailed, your success rate, the failure will be felt on left side also. So DPMO will now be 6.8. All of you understand how that number 3.4 is coming, the magic number?
Yeah.
Yeah.
All of you, do you understand the meaning of Six Sigma now?
Yes.
So if the process is like this, too much variation, it is hard to produce output meeting customer requirement. If the process is like this, very little variation, virtually everything you produce will meet customer requirement. That means your sigma levels will be in the order of 4.5 to 6. That means your yield will be very high, rejections will be very low. This is what is called the Six Sigma way of problem solving. Any problem in the world, including your company's problem, can be solved using this approach. The real-time problem is converted into a statistical problem, because we see all the problem through the statistical measures, nothing but average and standard deviation. The right average and right standard deviation can help us understand any problem. Correct the statistics. That is called a statistical solution. But how will you correct the statistics? You have to work in the field, work with the process, attaching more cars, training your drivers and all those things, right? This is called a Six Sigma way of problem solving. Every time the result can be delivered if the methodology is respected, if the tools are used with the right technique, right? And all other methods, in my opinion, are trial and error methods, right?
Yeah.
So the benefits are like, your organization's revenue can increase, cost can come down, and the resource utilization can increase. And most important, people in the organization will become more knowledgeable, more skillful. Do you accept this statement? Yes or no?
Yes, yes.
Yes.
Six Sigma projects, people who are working on Six Sigma projects will obviously become more knowledgeable, more skillful, and deliver results from the project. A knowledgeable and skillful person, if he becomes a leader, he will spread the culture. He will spread it throughout the organization, and Six Sigma can be a culture in such organization. So Sigma level is a measure of process capability. Specification limits are provided by customer. Control limits are calculated from the process data. A 3 Sigma process can assure a yield of 99.73, which is only short term. However, a 6 Sigma process, which is doubly capable, can assure a result of 99.99966%, which is a long-term result for a one-sided process. In a 3 Sigma process, control limit will overlap with the specification limit. In a 6 Sigma process, the control limit will be midway between the process center and the nearest spec. Higher the Sigma level, higher will be the capability. Higher the Sigma is problem, please understand. Sigma level is your capability, your strength, but Sigma is your problem, variation. So higher Sigma means your capability will come down. Hope it is clear to all of you.
Yes.
So any questions? Anything? Now we are done with the proper foundation. You can learn any tool now. You will know why are you learning the tool. Am I correct with my statement?
Yeah.
So any specific questions before we go for the lunch? Anybody would like to ask? No questions?
No, not as of
No,
now.
There are no questions? Okay, if there are no questions, show me, your level of understanding now with the thumbs up.
1 minute, sir.
Okay, who
Yes,
is
sir.
who
Yes,
is waiting the 1 minute? Yeah.
Certainly. The higher sigma level means, sir,
Higher capability.
higher capability. Okay.
Sigma means very,
Standard deviation variation. That means
yeah. We don't want
that's
more
not good.
variation,
Yes.
but we want more capability.
Okay.
Sigma level should be high. For that, sigma should be low.
Okay. Thank you.
So I could see only Tarun Kumar, showing the thumbs up. How about others? You are still not convinced?
It's okay. It's okay, sir. Nah, right now, so seems to be okay. Mm.
Sanjay, Savita, you have a doubt still? You can ask me.
No, I'm clear with it.
Then you can lift your thumb.
Sure.
Sanjay, I can see your kid now. So she also understood Six Sigma. Sorry, your son, I believe. All right. Thank you very much, all of you, for your patient listening. So you will continue to learn in the same direction. And now we will take you through the next phase, measure phase tools, measure phase techniques, and then the deliverables, right? Pay complete attention in every session and try to master the tool without any deviation, without worrying about how you can use it in your current business. Definitely you will be able to use it, right? Be fully convinced that Six Sigma can help you. Six Sigma can help your company, and you should be ready to benefit out of it. Your organization should be ready to benefit out of it. If they wholeheartedly accept it, then no doubt Six Sigma can produce breakthrough results in your business, right? All the very best. We'll meet after lunch. So 2:15, can you all assure to come back by 2:15? Is that
Yes.
okay?
Yes, sir.
Yes, because I consumed some extra time. We'll adjust 10 minutes. 2:15 will be the starting time. Thank you.
Okay, sir. Okay.